Download this code from codegive.com, link in the description below. Mastering Pivot Tables in Pandas, a comprehensive guide with code examples. Pivot tables are a powerful tool in data analysis, allowing you to summarize and analyze data from a pandas data frame in a flexible and insightful way. They enable you to reshape your data based on different criteria, making it easier to identify trends, patterns, and relationships. This tutorial will guide you through the process of creating and manipulating pivot tables using the pivot_table function in pandas, covering various aspects from basic usage to advanced techniques. 1. What is a pivot table? A pivot table is a data summarization tool that rearranges and aggregates data based on one or more columns. It essentially transforms a data frame from a long format, where each row represents a single observation, into a wide format, where rows and columns represent different categories, and the cell values represent aggregated values. This allows you to see how values in one column relate to values in other columns. 2. Prerequisites. Python *. You should have Python installed on your system, version 3.6 or higher is recommended. Pandas *. Install the pandas library using pip install pandas. 3. Setting up your environment. 4. Creating sample data. Let's create a sample data frame to work with. This data frame will represent sales data for different products, regions, and months. This will print the data frame. 5. Basic pivot table creation, the pivot_table function. The core function for creating pivot tables in pandas is pivot_table. Here's its basic syntax. Let's break down the key parameters. *data * the data frame you want to pivot. *values * the column S to aggregate. This is the data that will fill the cells of your pivot table. If none, it will try to aggregate all numeric columns. *index * the column S to use as the index rows of the pivot table. *columns * the column S to use as the columns of the pivot table. *aggfunc * the aggregation function to use, example mean, sum, count, min, max, std, var, or a custom function. Defaults to mean. *fill_value * the value to use for missing values, nans. *margins * if true, add subtotals along the rows and columns, defaults to false. *drawn * if true, drops columns where all values are nan. *margins _name * name of the row / column that will contain the totals if margins is true. *observed * only valid if any of index or column are categoricals. If true, only show observed values for categorical groupers. If false, show all values for categorical groupers. *sort * the resulting data frame. Example 1, average sales by region. Let's create a pivot table showing the average sales for each region. Output. This shows the average sales in each region. We've used sales as the values, region as the index, and the default aggregation function mean. Example 2, total quantity sold by product and month. Let's create a pivot table showing the total quantity sold for each product in each month. Output. Here, we've used quantity as the values, product as the index, month as the columns, and sum as the aggregation function. Example 3, sales and quantity by region and product. Let's create a pivot table showing both total sales and average quantity for each region and product. We can pass a list of columns to the values argument and a list of aggregation functions to the aggfunc argument, if we want different aggregations for each value. Since we want the same aggregation, sum, across sales and quantity, we just use a single string sum. Output. Now, we have a multi-index pivot table with both region and product as rows. 6. Handling missing values with fill_value. If your data contains missing values, nans, they can appear in your pivot table. The fill_value parameter allows you to replace these nans with a specified value. Output. In this case, any nan values in the sales column when creating the pivot table are replaced with 0. This can be helpful for preventing errors or improving the readability of your pivot table. 7. Adding subtotals with margins. The margins parameter adds subtotals, margins, along the rows and columns, giving you a grand total and subtotals for each category. Output. Notice the all row and column, which represent the grand totals and subtotals. You can change the name of the all column with the margins_name parameter. 8. Multiple aggregation functions. You can use multiple aggregation functions in your pivot table. To do this, pass a list of function names or functions to the aggfunc parameter. Output. Now, the pivot table shows the mean, standard deviation, and sum of sales for each region. 9. Custom aggregation functions. You can also use custom aggregation functions. These can be lambda functions or regular functions. Output. Here, we defined a custom function range_func that calculates the range, difference between maximum and minimum, of the sales values. We then used it in the pivot table along with the mean function. 10. Categorical data and observed parameter. When your index or columns contain categorical data types, you can control whether to show only observed values, the actual categories present in the data, or all possible categories using the observed parameter. By default, all categories are shown. In this example, we convert the region column to a categorical data type. By setting observed equals true, we ensure that the pivot table only shows the regions that actually appear in the data frame. 11. Sorting the pivot table, sort parameter. The sort parameter, default, true, controls whether the resulting pivot table is sorted. If you set sort equals false, the order of the indices and columns will be as they appear in the data. The output order might differ from the earlier examples due to the absence of sorting. It'll be based on the order region appeared in the original data frame. 12. Dropping columns with all nan values, drana parameter. If drana equals true, default, columns that contain only nan values will be dropped from the pivot table. You can prevent this by setting drana equals false. This is often useful if you intend to fill the nan values later. Output will include a column with the header nan. If drana equals true, this column would not be included. 13. Styling and visualizing pivot tables. While pandas itself doesn't provide extensive styling options for pivot tables, you can use libraries like Matplotlib and Seaborn to create visualizations based on your pivot tables. This will generate a heat map visually representing the average sales by region and month. 14. Example, analyzing customer purchase data. Let's consider a more practical example with customer purchase data. Assume you have a data frame like this. We can use pivot tables to answer questions like what is the total amount spent by each customer? Which products were purchased by each customer, using count as an aggregation. This gives you the number of times each customer bought each product. Average amount spent by customer for each product. 15. Advanced techniques, groupie and pivot table combination. Sometimes, you might need to perform more complex data manipulation before creating a pivot table. The groupby function can be used in conjunction with pivot_table to achieve this. For example, let's say you want to calculate the percentage of total sales for each product within each region. You can't directly do this with just pivot_table. This example first groups the data by region and product, then calculates the total sales for each region, and finally calculates the percentage of sales for each product within each region. The resulting data is then used to create the pivot table. 16. Tips and best practices. Data cleaning. Ensure your data is clean and consistent before creating pivot tables. This includes handling missing values, correcting data types, and standardizing text. Choose the right aggregation function. The appropriate aggregation function depends on the type of analysis you're performing. Sum, mean, count, min, max, and custom functions are all useful in different situations. Experiment with different pivot table structures. Try different combinations of index and column variables to explore your data from various perspectives. Use visualizations. Complement your pivot tables with visualizations to make your findings more compelling and easier to understand. Consider data scale. For very large data sets, pivot tables can be memory intensive. Explore alternatives like Dask or Spark for distributed data processing. Understand your data. Before creating any pivot table, take time to understand the meaning and relationships between the columns in your data frame. This will help you choose the right parameters and interpret the results correctly. Explore cross-stab. Pandas also provides the cross-stab function, which is a specialized version of pivot_table designed for counting frequencies between categorical variables. It's a great tool for creating contingency tables. 17. Conclusion. Pivot tables are a powerful and versatile tool for data analysis in Pandas. By mastering the pivot_table function and understanding its parameters, you can effectively summarize, reshape, and analyze your data to uncover valuable insights. Remember to practice with different datasets and scenarios to become proficient in using pivot tables for your data analysis needs. The examples provided here are a starting point. Adapt and experiment to unlock the full potential of pivot tables in your own projects.